This is our astronomy unit. We are in the solar system, and specifically this lesson is looking at the outer planets. In the 1840s, astronomers were puzzled. Uranus didn't move as expected based on the theory of gravity. Astronomers John Couch Adams and Urbain Le Verrier independently hypothesized that Uranus was being affected by another planet's gravity. They calculated where this planet should be. Another astronomer, Johann Galli, aimed his telescope at the place Le Verrier predicted. On September 23, 1846, he discovered the new planet Neptune. So again, we are in the outer planets. Let's take a moment and look at what the outer planets are. Jupiter is the first of the outer planets. The outer planets are also known as the gas giants or the Jovian planets. After Jupiter comes Saturn, and then Uranus, and finally Neptune. So what do the outer planets have in common? If you could visit the outer planets, you wouldn't have a solid place to stand. The four outer planets are much larger and more massive than Earth, and they do not have solid surfaces. Because these four planets are so large, they are often called the gas giants. The picture that you see here summarizes some of the different attributes of each of the gas giants. We can see the diameter in comparison to one another, the period of rotation, and please notice this is in Earth hours, the average distance from the Sun measured in astronomical units, the period of revolution. Also notice here this is measured in Earth years and not Earth days, and then finally the number of moons. Jupiter and Saturn are composed mainly of hydrogen and helium. Uranus and Neptune contain some of these gases, but also ices of ammonia and methane. Because they are so massive, the gas giants exert a very strong gravitational force. This gravity keeps gases from escaping, forming very thick atmospheres. Despite the name gas giant, much of the material in these planets is actually liquid because the pressure inside the planet is so very high. The outer layers are extremely cold because they are far from the sun. Temperatures increase greatly within the planets. All of the gas giants have many moons, ranging from 13 around Neptune to more than 60 around Jupiter. These moons vary from tiny balls of rock and ice, barely a kilometer across, to moons larger than Mercury. Some of these moons even have their own atmospheres. In addition, each of the gas giants is surrounded by a set of rings. A ring is a thin disk of small particles of ice and rock. Saturn's rings are the largest and most complex. So what are the characteristics of the outer planets? Since telescopes were first invented, scientists have studied the features of the outer planets and their moons. Today, space-based telescopes and space probes, including the Voyager, Galileo, and Cassini, have revealed many details of these planets that are not visible from Earth. Scientists are constantly discovering new information about these planets and their moons. So let's start by looking at Jupiter. Jupiter is the largest and most massive planet. Jupiter's enormous mass dwarfs the other planets. In fact, its mass is about 2.5 times that of all the other planets combined. Like all of the gas giants, Jupiter has a thick atmosphere, made up mainly of hydrogen and helium. One notable feature of Jupiter's atmosphere is its great red spot. It is a storm that is larger than Earth. The storm's swirling winds are similar to that of a hurricane. We can see in the picture of Jupiter here, this is the Great Red Spot. Astronomers think that Jupiter probably has a dense core of rock and iron at its center. A thick mantle of liquid hydrogen and helium surrounds this core. Because of the weight of Jupiter's atmosphere, the pressure at Jupiter's core is estimated to be about 30 million times greater than the pressure at Earth's surface. Jupiter has a large number of moons. Ganymede is Jupiter's largest moon. It is larger than Mercury. Its surface is divided into dark and bright areas. Callisto is second in size to Ganymede, but has less ice. It has the most craters of any of the moons of Jupiter. Io is not icy. Unlike most of Jupiter's moons, it may have as many as 300 active volcanoes. The eruptions from those volcanoes constantly change the moon's surface. Europa is covered with ice. There may be liquid water below the ice, and if there is, there could also be life. So again, the moons of Jupiter are, at least the largest ones, Ganymede, Callisto, Io, and Europa. The second largest planet in the solar system is Saturn. Saturn, like Jupiter, has a thick atmosphere made up mainly of hydrogen and helium. Saturn's atmosphere also contains clouds and storms, but they are less dramatic than those on Jupiter. The Cassini space probe found unusual six-sided cloud patterns around Saturn's north pole. Scientists still are not sure what causes these patterns. Saturn has the most spectacular rings of any other planet in our solar system. These rings are made of chunks of ice and rock, each traveling in its own orbit around Saturn. From Earth, it looks as though Saturn has only a few rings, and they are divided into a number of narrow dark regions. Space probes have shown that each of these obvious rings is divided into many thinner rings. Saturn's rings are broad and thin, like a compact disk. Some rings are kept in place by gravity from tiny moons that orbit on either side of the ring. Saturn's largest moon, Titan, is larger than the planet Mercury. It is also the only moon in the solar system that has a thick atmosphere. The atmosphere is composed mostly of nitrogen and methane. Some of these gases break down high in the atmosphere, forming a haze that is somewhat like smog on Earth. In 2005, the Huygens probe landed on Titan's surface. Photos from Huygens show features that may have been formed by flowing liquid. A few scientists think that Titan might support life. Scientists have learned a great deal about Saturn's moons from the Cassini space probe. Giant craters and trenches cut across Mimas and Tethys. Ice and water erupt in geysers from the surface of Enceladus. And in 2009, scientists discovered a ring of material that may have come from the outermost moon, Phoebe. So looking at the moons of Saturn, Titan has a very thick atmosphere and is the largest of those moons. Mimas has a giant impact crater. Lepidus, it has dark and light areas. Tethys is a very circular shape. And Enceladus has plumes of erupting volcanoes that spew material out of the surface. The next planet in our solar system is Uranus. Although the gas giant Uranus is about 4 times the diameter of Earth, it is still much smaller than Jupiter and Saturn. Uranus is twice as far from the Sun as Saturn, so it is much colder. Uranus looks blue-green because of traces of methane in its atmosphere. Like the other gas giants, Uranus is surrounded by a group of thin, flat rings, although they are much darker than Saturn's rings. Photographs from Voyager 2 show that Uranus's 5 largest moons have icy cratered surfaces. The craters show that rocks from space have hit the moons. Uranus's moons also have lava flows on their surfaces, suggesting that material has erupted from inside each moon. Voyager 2 images revealed 10 moons that had never been seen before. Recently, astronomers discovered several more moons for a total of at least 27. Uranus's axis of rotation is tilted at an angle of about 90 degrees from the vertical. This means that Uranus almost acts like a bowling ball rolling around the Sun. Viewed from Earth, Uranus rotates from top to bottom instead of from side to side as other planets do. Uranus's rings and moons rotate around this tilted axis. Astronomers think that billions of years ago, an object hit Uranus and knocked it on its side. Images from Voyager 2 space probe allowed scientists to determine that Uranus rotates in about 17 hours. Neptune. Neptune is similar in size and color to Uranus. Neptune is a cold blue planet. Its atmosphere contains visible clouds. The color comes from methane in the atmosphere. Neptune's interior is hot due to energy left over from its formation. As this energy rises, it produces clouds and storms in the atmosphere. In 1989, Voyager 2 flew by Neptune and photographed a dark spot about the size of Earth. Like the Great Red Spot on Jupiter, the Great Dark Spot is probably a giant storm, but it didn't last long. Scientists have taken a number of new images. They occurred 5 years after the first image, and that spot was gone. Astronomers have discovered at least 13 moons orbiting Neptune. The largest moon is Triton, which has a very thin atmosphere. Voyager 2 images show that the area of Triton's south pole is covered by nitrogen ice.